Welcome to lesson 4 of week 3. In this lesson, we're going to look at sets in Python. My name is Mildred. Sets is another type that we can use to hold several values in one variable. A set is one of the most useful and unique data type that we can use to perform several operations that we'll see when we start building our apps in the advanced course. A set is not ordered, so you can't know the order in which they are. So in our list and tuple lesson, we have seen that we can refer to an item by calling their index position. But in a set, you cannot do that because you don't know in advance what order your item are in, and the item orders change. Now, sets only store unique values, and that is that unique property that's used a lot in software development. And also, they are unchangeable. You can update the item once it has been created, but you can add and remove items. So they are unindexed, unordered, they are unchangeable, and then they are also unique, do not allow duplicate. In the sense of duplicate, true and 1 are seen as the same in a set, and false and 0 are seen as the same in a set. So if you have a set that has false, it will not accept 0. If you have a set that has true, it will not accept 1. So let's create a set. We use a pair of curly braces to create a set. So it's just like you create a list, but instead of the square bracket, we use curly braces. So let's say students. Okay, so this is how we create a set, and we can have two sets. Let's create two sets so that we can use this to illustrate something else later. All right, so let's print this out before we start. So we're printing out students, and then I'll run this and we can see the students. So you can see that the order in which it is printed out here is not the same order in which it is listed. If I run again, it will change its order. So you can see that. So the sets is unordered, it just presents itself anyhow. So you won't know how it's going to be presented. You can also use a set constructor. So instead of us using this, we can say set and a pair of double parentheses like this create the set. So this is one way that we can create sets. So since we see how unordered they are, we know that we cannot refer to a set by using their index, but we can add an item to the set, and we use the add method to do that. And we want to add into this set, we want to add. Now notice that in new students there's Eve and Frank. I want to use this to illustrate that when we combine them, it will not accept duplicate values later on. So let's print students to see that Eve and Frank are added to the students. So if I want to combine these two sets together, so I can use the update method to do that. Student.update like this, and I will specify the name of the variable that holds that new student. And so when I print students now, I'm going to get a new set or an updated set, but we won't see a difference because we've added Eve and Frank previously, and this new student wants us to add Eve and Frank. So it's going to reject the new ones and just print it like that, so it won't add duplicate. So we can remove an item by using the remove method. And if I use remove like this, let's say remove Eve. Now notice that at this point Eve is not added to the student yet. We just have two separate sets. Eve is not added, and so this will result in an error because Eve is not yet present in that set before I try to remove Eve from the list. So we'll get that error here that Eve does not exist. But if I remove Eve after this update, then now Eve is going to be removed without an error. If you don't want to have that error, we will use a discard. So let's move this up here, and then let's use discard here instead of remove. It's going to just fail silently without giving us any error. So it just ignores it because Eve doesn't exist. So if you don't want to raise errors, you use discard. If you want to make sure there is an error, make sure you handle your errors, you use the remove method. We can also combine a set and another iterable, like a list and a tuple and a dictionary. It's not just the two sets that we can combine. So when we use some of this method, we'll look at it later, we'll see that we can only use some operators on two sets, but when we use certain methods, we can now use it on a set and any other data type, and we'll look at that later. Let's add a new list here, not a set now but a list. Let's say we want to have transfer students. So we have these transfer students that we use to illustrate other methods, and we'll see the effects that it will have when we want to combine a set and other types using certain operators, and when we want to do set and set. So one of the first we'll look at is the union method, right? When we use the union method to return a new set, and that set will contain items from both sets. And if what we combine is a set and another type, it will return the items from both. So let's say we want to use the union method. The union method will allow us to combine two sets or a set and another type. So this is a list. Let's try to combine student and transfer student. So we can have new set is equal to, and when we print new set, we see it prints out nicely, combining everything from students and transfer students. But in place of the union, we can use this operator. We can use this operator, but this operator will only work on two sets. Now we try to combine a set and a list. This will give us an error because this operator, while it works at union, it will only work on two sets. So we have until we change this to, let's use new students, that is a set, and then this will combine both sets together and give us the new set. So take note that you can use union or this operator, and this operator will only work on two sets, while the union method will work on a set and any other data type that you use. So we have something called the intersection method that will return a new set, and that set will contain only items that are present in both of the iterable. When I say iterable, I mean the set and any of the other type. So if we want to use the intersection method, for instance, let's say, so in this list there's Alice and I want to use the intersection method, right? And so when I print out new set is empty. So we say students dot intersection new students. There's no intersection, so it's empty. But we're going to be comparing with the transferred student list. And now we're going to print out Alice because Alice is the only common item between both. So you can see what happens when there is nothing. It prints out empty sets. When there is a common item, it gives us that item. Another operator that we can use in place of the intersection, and this operator will work only on two sets. So let's say instead of this we want to use the AND operator, like this, the ampersand sign, and this will not give us the desired value but an error because we are comparing a set and a list. And so we'll get the error because it's set and a list. But two sets, students and new students, will now combine properly because they are both sets. So it's going to work like the intersection but only with both, and with both we have nothing in common. Assuming we put Bob here and there are two Bobs, so there's Bob in common with both sets, then we're going to have Bob printed here. So instead of intersection like we did before, let's say dot intersection, we can do intersection update like this. Now the difference between intersection and intersection update is that the intersection update does not create a new set, but just update the original set that we already have. So what we'll do here is just say student dot intersection update new students like this, and so we'll print out students. So what it does is update the original one with the value that is common to both sets, which is Bob. And so when you print out students now, it has been replaced using this intersection update. We have another method. We call this method the difference method. So written difference. So we have the difference method, and the method returns a new set that contains only items from the first set that is not present in the other set. It will return Alice, Charlie, David because Bob is present here. It will return Bob. So it's going to give you uniquely what is in students that is not in this when we use the difference. So when we print out diff set, we should get everything that is in students that is not in new students. Alright, so Alice, Charlie, David are there, and Bob is not included because Bob is in new students. There is another operator we can use instead of the difference, which is a minus operator, and just like the other method we've seen with their operators, you can only work on two sets. Now we have two sets. It's going to go fine because we're working on two sets and we'll get the same value. But if we try this with transfer students, it's going to result in an error because it is not a set. Transfer student is a list. So we have another operator we call the symmetric difference. Now the symmetric difference method returns elements that are present in only one of the sets. So anything that is present in only one will be returned, and the symmetric difference has its own operator, this, that allows you to compare two sets and get the same intention like the symmetric difference, but it does not allow you to compare a set and something else. So let's look at the symmetric difference so you know what it does. So when we compare students and transfer students, is going to look for what is common in both, right? And what it's going to return to us is a set that has elements that are present in only one of the sets. We have Alice is present in one, Alice is present in this one. It's not going to return Alice. So it's return Bob, Charlie, David, Adam, James, Paul, and remove the Alice because both of them have Alice in common. Then we also have the operator that will allow us to compare two sets the same way like a symmetric difference. It won't allow us to do that with a list but with another set. So we'll put like new students and we remove this and use that operator. And so we get Eve is unique, Frank is unique, Bob is not unique. So have Eve, Frank, Alice, Charlie, David. So in the event that you have a list and you just want to get unique items, you will know what you convert to from a list to a set to make it unique, and then convert back to a list to give you only unique filtering. So there are other methods that we can use to perform destructive operations, like when you use the pop method like we did in list. The only problem you will have with this is you won't know what is going to be removed. Since they're not ordered, you can just take out any item. So if I say student, it's not going to take out the last item but a random item. Let's print student and see what it took out. So we have Bob, Alice, David. So it took out Charlie this time. We can use the clear method. So when we say students.clear, it's going to empty the items from the student set. And so the set is now empty, returns an empty set. And if you want to delete it, you can say delete, use the delete keyword, student. And this time we'll get an error when we want to print students because it doesn't exist anymore. It has been deleted. So this is all you need to know about sets. You can research further to see any method we must have left out, but we've looked at most of them. You have to practice more to get a better understanding. Continue to compare the different attribute data type lists to full sets. And in the next lesson, we're going to look at dictionaries. Thank you and see you in the next lesson.